Welcome everyone. On behalf of AgResearch, I would like to welcome you to this lunchtime webinar, Dairy Energy Efficiency and Renewable Options. Before we start, just a few items of housekeeping. You are automatically muted. Use the Q&A function, not the chat box, to ask questions. You can upvote questions that you want to be answered. If you have issues, leaving and rejoining will usually fix them. And the webinar will be recorded and available later on the AgResearch YouTube channel. And also, as always, we'd be very grateful if you could complete the feedback survey, which will appear at the end of the webinar. The dairy sector is a large user of electricity. In order to mitigate these rising costs, it is important that dairy farmers take steps to reduce their energy dependency. Options available include improving efficiency of energy use and incorporating renewable electricity. The first speaker taking place tonight will be Dr. John Upton from Teagasc Moor Park. Dr. Upton has research interests in direct and indirect energy consumption on dairy farms, renewable energy integration and management, milking machine performance, and milking management. Dr. Upton will be speaking on strategies to reduce energy consumption on dairy farms. So I'll hand over to John now.
Thank you, Jason. Good afternoon, everyone. Share my slides. Okay.
That's you, yep.
Hope you can all see the slides and hear me speaking. So it's an honor to speak to you this afternoon. I'll just run through a little bit in terms of the research that I've been doing here at Moor Park on increasing energy efficiency on dairy farms. We'll cover some of the basics in terms of where the costs lie, and we look at some technologies that can be used to deploy on farms in terms of reducing energy usage. I suppose I'm always beating the drum of applying an efficiency first approach to this area. So that's the way we'll run with the presentation, and then we'll look at some renewable options as well to finish up. Okay. So I suppose I started researching this area myself back in about 2009, and we ran a fairly large energy auditing project here within Teagasc for about 6 years, where we measured the energy consumption of dairy farms in depth every 15 minutes. We had about up to 80 farms in this project by the end. And it allowed us, I suppose, not only to look at where the energy is going in terms of all the pieces of equipment, we monitored everything individually. So we were able to look at the breakdowns. So what we found really is that milk cooling is consistently the biggest cost inside the farm gate, and that is representing about 31% of total energy demand on the farms that we were working with. I suppose I should mention just before I go any further that the farms that I'm working on here were in the south part of the country, and they're predominantly, I suppose, the spring calving grass-based system, okay? But we did have a good spread in terms of herd size and so on in the study. Moving on from milk cooling, your water heating is also a considerable portion of the bill, approaching a quarter of overall energy consumption there. The milking machine itself is about 20%, and that's driven primarily by the vacuum pumps within the milking system. The other portion there would be 18%, and that includes winter housing and workshops. Your water pump is relatively small at 5%, and your lights are around 3%. Okay. In terms of the costs of electricity, then these would be current costs adjusted for the present electricity prices. They're coming in at about 12 euros per 1,000 litres of milk sold. Or to put it another way, I suppose, the average expected bill for a 100 cow farm is in the region of about 6,000 euros plus the VAT. And there's a big range, I suppose, within farm performance, and we're seeing the most efficient farms coming in at about the 7.50 euros mark per 1,000 litres, and the more energy intensive operations being up around the 14 euro level. So I suppose your robotic systems would tend to be on the higher end of the scale, and I would expect any kind of indoor-based systems to be slightly higher as well, more towards the 14 euro level rather than the 7.50 level. I suppose if you look at it in terms of energy use per cow per year, the average on my study is about 240 kilowatt hours of electricity consumed per cow per year. Okay. Look, in terms of reducing costs, your simple wins are to look at the unit rates, and in particular, I suppose, try and shift as much of the consumption over to the nitrate area as possible. And goes out saying that, I suppose, benchmarking your unit rates in terms of searching for the cheapest supplier every 12 months, that message has never been more important than it is now. And there's big differences in the market between being in a contract for electricity and being out of a contract. We look now at the technologies. We'll just pick out a couple of key technologies to look at in terms of energy efficiency. And I suppose on the cooling side of it, your plate cooler, the good old plate cooler, is kind of hard to overlook. It's probably the most efficacious piece of technology that you could deploy on a dairy farm to cut energy costs. And the plate cooler, of course, will just use well water to chill the milk down considerably before it goes into the bulk tank. And the goal of the pre-cooling system is to cool the milk to within 5 degrees Celsius of incoming water temperature. So if, for example, the well water was coming into the dairy at 10 degrees, you would be looking to cool the milk to 15 degrees before it goes into the bulk tank. Okay, so you're taking out roughly half the energy from the milk before it ever goes into the tank. The reason I like that temperature differential as a metric is because it's easy to look at it on farm. The old recommendations, I suppose, were based on the milk to water flow ratio, which is a bit more difficult to assess on farm. But if your temperature differential is correct, it means the ratios are correct. Okay. The plate cooler can reduce milk cooling energy use by 40%. So very, very powerful piece of kit. I suppose the work that I've done has shown that about 90% of farms would actually have a plate cooler in place. But the average milk to water flow ratio across the farms in my study was only 1 litre of milk to 1 litre of water. So I was only doing half a job, if you like. And I guess the message there would be to assess the performance of the plate cooler and just assume that it's doing its job. It's important to look at how effective it's operating. To achieve the levels of cooling here that I'm talking about, it's important to not only have adequate pipe sizes coming to the plate cooler and also away from the plate cooler. It's also important to look at the type of milk pump that's deployed. So a variable speed drive milk pump would be much more beneficial in terms of allowing the water to do its job than a high speed milk pump. Okay. Moving on to the milking machine, I suppose your go-to technology here in terms of reducing costs are the variable speed drives, or the VSDs. These VSD units will simply reduce the vacuum pump speed when demand for vacuum is low, and it will increase the speed of the pump when demand for vacuum is high. For instance, if you're attaching units in the pit, the pumps will ramp up, or if there's a unit fall off, or during washing. But for the vast majority of milking time, the pump is only spinning at about 30% of its full speed, and therefore big savings are possible. From the work that we've seen, it's typically you're saving 60% on the running of the vacuum pumps with this VSD technology. I guess in terms of return on investment then, it's very good on 3-phase farms because these inverters tend to be more reasonably priced when all they're doing is taking in 3-phase and outputting 3-phase. On single-phase farms with 230 volts, it's also possible to fit this technology, but the drives tend to be more expensive and therefore the return is not as good. Moving on to water heating, I suppose before we speak about efficiencies, we just mentioned the requirements. Adequate supply of hot water is critical to ensuring adequate cleaning of the milking systems. And we're looking to heat about 10 litres of water per milking cluster in terms of capacity, and that should be around 80 degrees or so. And also 2% of the volume of the milk tank, and that can be a little bit lower temperature. 70 degrees is sufficient there typically. Okay. In terms of water heating running costs, where they're sitting currently is obviously much higher than they were 12 months ago. But day rate electricity, it's currently costing about €4.18 to heat 100 litres of water from cold to hot. €2.09 on night rate electricity. €1.17 on LPG or gas, and €1.22 on oil, kerosene. So I've included the prices of the fuels there on the bottom of that slide as well. So gas currently would be the cheapest source for heating water on farms. Okay. In terms of improving the efficiency then of any of those electricity, oil or gas fired systems, I guess the heat recovery unit is the go-to technology. So these heat recovery systems, they're pretty simple really in theory. They remove heat from the milk cooling system as the refrigerant is circulating through the tank, and it transfers that heat energy via a little plate heat exchanger into a tank of water. So it's preheating a buffer tank of water up to 40 or 50 degrees, thereby reducing your water heating running costs by 40 to 50%. So the return on them is very good. It's possible to install them into existing systems, and it would be advisable probably to put them into any new tank going forward, because it'll be much more economical to build in from day one. Moving on now to, I suppose, the more renewable stuff, and the specifically solar or photovoltaic technology is probably the go-to renewable system for dairy farms going forward. This is distinct from solar thermals. These solar or photovoltaic panels, they generate renewable electricity from the sun, and then that can be used within the farm while there's demand inside the farm gate, or exported out to the national grid in times of excess. Going forward, at least in this part of the world, sizing these for self-consumption is probably going to be key to generate a positive return on investment on them. There's a big mismatch between supply and demand on farm. I'll show you that on the next slide. And as a result, it's necessary to use some form of energy storage within the farm gate to balance out the supply-demand mismatch between dairy farm energy use and supply of power through these PV systems. And that energy storage can be provided with a simple water heater, a simple electrical water heater, with batteries, or with some kind of ice bank technology. Similarly, there's a big gap between what we get paid to export here and the day rate. So our current export tariffs are somewhere between 14 and 20 cents per unit for a unit that we sell off to the grid, whereas our day rate is approaching 40 cents per unit. So therefore, the payback on these solar PV systems would be much better if we can use more of the power inside the farm gate. Panels and their size in terms of this kWp, which is a kilowatt peak, and 1 kilowatt peak of panels will typically generate somewhere around 850 units of electricity per year over its lifespan. Some will do more, some will do less. That's worth about €340 at day rate, and 1 kilowatt peak of panels takes up in and around 5 meters squared of space, of roof space. What we've got here on the slide is a supply, a demand, I suppose, illustration of what's happening on farms. We've got a portion of energy consumed here by the farm on the y-axis, and the time here along the x-axis. So our orange is our rotary farm load profile. So we see two big spikes in demand, one for morning milking, one for evening milking. Not much going on during the day, a little bit here, and very little at night either, because most of these big farms, what we're seeing is that they have oil or gas water heating. Therefore, there isn't too much of demand at night time either. Our herringbone load profile has, again, our signatory peak for morning milking, peak for evening milking, and a little bit more load here at night time, and that's your water heating demand. Typically, those farms would have electrical heating systems, and the robotic milking system then is in grey, so that would have a more even demand, I suppose, for electricity than the other two types of systems. And then we've got our solar radiance there in yellow. So you can see your PV system will generate most of its power here between milkings, which is somewhat of a challenge in the sense that if we sell all this power off here that's generated in the middle of the day for cheap, the payback on our system won't be as good as if we could use some of it here in the middle of the day. So I suppose that's the challenge, the technical challenge that exists around this technology on farms. But as I mentioned earlier, there are ways around it by using some form of energy storage. In terms of grid connection, then we have a couple of different schemes. We have our microgen scheme, which is for smaller systems. We have our mini gen scheme for larger systems, up to 50 kilowatt peak. But I suppose our connection limits, they're still limited by the maximum import capacity of the farm, which is in most cases 29 kVAs. More information on all those connection options are available there on the ESB network websites. The exports and other supports. So we mentioned earlier our clean export guarantee down in this part of the world is between 14 and 20 cents, which is much lower than it needs to be really. There's accelerated capital allowance schemes available. VAT recovery is also available on them. Planning has been abolished down here now for roof mounted systems, which is a very positive step forward. And it looks like there'll be a very substantial grant in 2023 to the tune of 60% for solar PV systems. So it's likely that the solar panels will really take off next year, driven by this TAMS3 scheme. The payback without a grant is still pretty good, 6 to 7 years. But imagine if you could get 60% off that, it would really be a game changer. So I suppose in terms of what Teagasc are doing then in supporting the renewable transition, we have developed this dairy energy support tool. I've included a link to it here. And the ethos of this is that we would provide, I suppose, more tailored advice on a farm-to-farm basis, depending on herd size and so on. And this is just a quick overview of what the interface looks like. So you can put in the location of the farm, the herd size, morning and evening milking times, and a few other infrastructural details. And then on the right, you would click the size of solar panel system you want. It'll also do VSDs and heat recovery, put in the investment cost, level of grant aid supported, and it'll give you your nice load profile, your generation profile. It'll spit out as well your carbon offset, your portion of renewable electricity that's contributing to the overall farm use. And it'll also give you a simple payback period, which is, I guess, a bit more useful than me giving general payback figures. This will give you a more tailored figure for the piece of technology that you're interested in. And just to sum up, if we look at what these things might look like in terms of payback and CO2 savings on a 100 cow farm, the plate cooler has a very good return on investment, saves about 2.5 tons of CO2. The VSD has a good payback for 3-phase farms, a little bit longer on single-phase farms, as I mentioned, 1 ton of CO2 reduction. The heat recovery system is typically a 3 or 4 year return and 1.6 tons of CO2 saved. Solar PV could be as low as 2 or 3 years with a decent grant, or more like 7 without the grant, and there's about 4.6 tons CO2 saved as well. That's even at a moderate size system. So you could save roughly in the region of 10 tons CO2 per year on a 100 cow farm by adopting these energy efficiency practices. And the average payback at current energy prices would be around the 4-year mark. So I suppose the economics of these pieces of technology has never been better than it is, driven by increases in energy prices. And look, we've seen here that it's very achievable to reduce energy use, we would say, on a net basis by 20%, and also generate 50% of power demand on the farm through renewable sources. And we have this energy support tool available there online to help inform decision making on that side of things. So I'll leave it at that, folks, and thanks for your attention.
Well, thank you very much, John. That was very informative and very interesting. And I know there'll be a lot of jealous farmers up here looking at some of those support schemes which aren't up here in the north. So we may have a chat about that later. Just to say, we'll take the questions at the end, but at any time, just go ahead and put your questions in the Q&A box there, and we'll take them all at the end. So I'm going to go on to our second speaker, which is Professor Jim Harkin, who's head of the School of Computing, Engineering and Intelligent Systems at Ulster University. He'll be discussing the findings of the Item ID project completed in partnership with AgResearch and Dale Farm with support from the Ulster Farmers Union and CAFRE. The Item ID project monitored energy on a number of farms across Northern Ireland and also analysed renewable energy generation utilisation on some of those farms. So Jim, without further ado, I'll head over to you. Thank you.
Thanks, Jason, and good afternoon, everyone. So that's good stuff. It's just to say there, my name is Jim Harden with Ulster University. I'm based in the McGee campus of Ulster, based in County Derry, Londonderry. And I want to talk about or give an example of a case study. So a project was funded by Ag Research and Dale Farm to look at energy monitoring within dairy farming, and also to look at how renewables are being used within the farm and the energy being generated and where potentially it could be used more effectively. So just to give a bit of background, first of all, that's just showing there some of the Ulster team members, Molly McElhone, Ryan Beveridge, myself, and James McGear, who worked with us on this project from the business perspective. I suppose just to give a bit of background about the team, we're from the Intelligent Systems Research Centre, so we do a lot of work with data, analysing it and using things like artificial intelligence to automate the analysis and visualisation of data. So we have a lot of experience in working with data from different sectors. But working within the dairy sector was new for us in this particular project. We have a lot of expertise in what we call embedded systems. That's installing data loggers. So what I'll talk about, installing the systems allow us to clamp different motors and vacuum pumps and read those values. A bit of background as well. We previously done a lot of work on energy monitoring and manufacturing, where we had a cross-border funded project with Limerick Institute of Technology and ourselves. And we had different companies, Dupuy and Intel, that we worked with to monitor energy consumption and manufacturing. And that project ran from 2012 to 2016. And from that project, we came back to invest in Northern Ireland, seeing an opportunity of looking at developing tools to analyse energy use within manufacturing facilities. And that helped us develop some insight into different manufacturing sectors. In 2018, we went on to an ICURE program, was trying to look at commercialising some of this. We've seen a real opportunity and a need within the dairy sector, and that's where it brought us to talking to Ag Research about maybe undertaking a case study to look at energy consumption within the dairy sector. So that's how, I suppose, give you a narrative how academics from a data analysis and AI background moved into the dairy sector to look at this challenge. So from that, we established the ITIMIT project, which is looking at, I suppose, two different phases. It was trying to measure and record data, that's energy data that's being used within dairy farms, looking at traditional and robotic. And that project ran from 2019 until 2021. And obviously during that period, we had COVID and had issues of trying to on site and install meters, and an interesting time. Phase two of that was also to go and look at clamping renewables like wind turbines and solar panels, seeing what's been generated, and to look at, is there opportunities where we could use this within the dairy farm. So no, as John mentioned, there are a lot of farmers would sell it back to the grid at a loss at the minute. So it was really to analyse what's coming out of the example farms. We looked at where it could be used. Now, this, I suppose, case study is small in nature compared to maybe some of the scale that John's been reporting on. We looked at 6 dairy farms within Northern Ireland, and some of those had robotic and some were traditional. So if I go on, just maybe just make clear about the problem, I think John's hit it well, but there's huge energy costs in milk production, and it's more exacerbated now, as we know, over more recent months as well. And I know people are diversifying, looking at moving away from electricity or combinations of that as well. There's a big challenge as well as visibility into the farm energy use of energy. You know, for a lot of us, it's more recently we're starting to see where energy is being used within the different vacuum pumps, water heaters, and chillers, whereas they're significant energy users. So there's still a challenge getting into that, and there's some work being done and trying to get that visibility through dashboards. And also, you know, there's still a problem understanding where best we can use renewables and what's been coming out and what's the right size of renewable sources to have to suit your need. And also the key challenge is reducing the CO2 emissions. So that scopes out the problem we had, and we're trying to address this to analyse that. So for us, we had to develop this, we call it pilot architecture, a way of going on site and find out where the significant energy users were. And from conversations from farmers, clearly it was looking at vacuum pumps, water heaters, chillers, and looking at ways of trying to install some unit to record that. So we looked at the solid monitoring units and clamping onto these examples here. Hopefully you can see my cursor. these units here, the monitoring units, and we looked at clamping into the connections to your vacuum pumps, your water heaters, and your chillers back at these units. And these units then wirelessly communicate information back to a repository for us at the university, so we could collect the data. And the focus of the project was trying to collect this data and analyze to see where energy has been used. And what we wanted to try and do from feedback from the farmers that we engaged with was try and distill down to what is the kilowatt hour usage per litre of milk or 100 litres of milk, what would that be? And the idea of this study was to try and look across the 6 farms, so the robotic compared against the traditional, and see what that kilowatt hour per 100 litre milk cost was. So this infrastructure here just gives us a way of collecting the information. So just moving on to some of the outcomes of the study. As I mentioned, we had 6 farms, farms 1 to 6, and they're shown here, farm 1 on the left and farm 6 on the right. And the y-axis here just looks at kilowatt hours per 100 litres of milk. And the bottom we have the different farm types. So the first one's robotic, and the other ones are traditional farms. And we've got the herd size there as well. And you can see they vary from small, medium to large. So small being 50, medium being around 100 plus in this case, and 250 being large in size. So from this, you can see that we're showing 4 different colors per farm, and that's across the months of January, February, and March. So for us, we looked at trying to install the meters and record information. And we had a lot of what we call unclean data in the data science world, that there was data missing. So we had a look at a period of time we had data across most of the farms that we could analyze. And these are the best months that we had. So from this analysis, we could see that when we looked at, done our calculations of working out the energy used for vacuum pumps, chillers, and water heaters, and consolidating together, we could work out what was the kilowatt hours required per 100 litres of milk. And from this, just at a high level, we can see that the robotic farm was the highest, and that reinforces what John was saying earlier. Typically, you can see with the robotic farms, there's more vacuum pumps being used, and their average use would be higher in terms of their automation process. So we could see that from this, that averaging, at the start was 4 kilowatt hours per 100 litres of milk for the usage. And if you look across, we can see that down come across as the larger farm here was the lowest, a traditional farm. A point to note here is that one of the benefits of monitoring energy as well is that we could see that in February here that there was a large energy use. So the kilowatt hours per 100 litre milk went up that particular time. And that came down to post-analysis, talking to the farmer that the condenser needed servicing, and that got serviced and brought their energy consumption back down. So there's benefits to monitoring energy, that you can identify issues within the farm where machines are wearing out or coming beyond their life expectancy and time to change them. What's interesting here, look, we have 2 farms that both are we class small to medium, between 50 and 70 herd sizes. Their energy here, robotics always going to be high. These both had no pre-cooling, so they had no water plate cooling that John had mentioned on his earlier slide. The rest of the farms had. So there's a big difference here, that these farms were looking at taking the milk directly from the cow into the water cooling tank. And that's going from basically 32 Celsius. And normally water plate cooling, John mentioned his there, you can get half that, roughly to about 6 Celsius it normally went into. So both these farms, while traditional, had higher energy consumptions against the other traditional, which is here and here, due to having no water plate cooling, no pre-cooling. The most interesting one that stands out is this larger farm. There's several factors why this farm was most efficient in terms of just having over 1 kilowatt hour of energy for every 100 litres of milk. They used variable speed drives, again, which John mentioned as a real energy saver. And also they had 3-phase power. So a lot of their motors were 3-phase, which are energy efficient as well. And what we did see over this study was that while your herd size increased, you have more litres of milk being produced, your vacuum pumps are pumping more. We did see that for those farms that typically their water that they're heating for their yard, for parlour and the tanks would typically remain constant. So as your energy costs up for your vacuum pumps, you didn't see the water heating going up at the same scale. So that was a huge bonus in the sense that you could, as your hair sizing up, your water energy costs were not going up at the same scale. So for us, clearly, reinforcement John's point was variable speed drives and looking at moving towards 3-phase motors is really another way of trying to reduce your energy costs. And we can see that from this study. Just want to move on to talk about, we monitored the energy consumption energy generation from the renewables. We had a solar panel, and this is one example farm. So what's shown here is the time scale for a 24-hour period in the bottom. And on the y-axis, we have the watts of power. So this is watts, not kilowatts, kilowatt hours, sorry. What we can see here in the morning or over during the night is the water tank being heated. And then moving on, the water tank for the powder wash being heated as well later. And what I have here in this pink color is the energy being consumed for morning milking, and likewise for milking in the evening as well. What I have here in green is the solar. So this is energy being generated by the solar during the day, and it peaks around midday and then tapers off in the evening. And what this does is gives us a profile of when energy is being consumed within these areas, so the morning and the evening, and the energy generation is occurring outside of that. So we have this case, as again, John mentioned, that we have consumption occurring at the tail ends, at the left and right of our day, and the generation occurring during the daytime. And often a lot of farmers would look at maybe using this to drive the housekeeping, the lights, or sell it back to the grid. So it's looking about how can we make use of this energy that's being generated during the day, and rather than selling it back to the grid, how can we use on the farm? That's part of the study. So what we looked at was, we could see there's a certain number of hours that is being used during the night to heat the water. And our proposition was to try and let's use the renewables that's coming in during the day, the solar, and try and look at heating the water and the powder tanks or the tank wash, so that you're not using, even at the lower rate, you're not looking at using that at night time. So for us to try and be practical about that, we thought, how could this be done? What's the practicalities of it? And clearly for us, there's some innovation in developing a heater controller, where if you have your, for example, Cotswold water tank, your heater, that you're connected to the grid and you're connected to your solar, and that during the day as energy is being generated, we could look, the controller could look at taking from the solar panels or the wind and using that to turn on the water heater. And clearly there's a set temperature from what we've seen, normally around 80 Celsius, of what farmers would set their water temperature to ensure that it's hot enough for washing. So the concept we're looking at is trying to dig in cold water, and as renewable energy is available to heat up the water tank, and there's more renewables available, take in more cold water and start heating up the tank until you get up to your full tank ultimately, and at your 80 Celsius. Or if you have a full tank, to try and maintain that 80 Celsius temperature for as long as possible. What we've done from our analysis from clamping the solar, we knew how much solar was coming in on an average good day. And we could see from morning time, we could roughly get about 1.5 kilowatt hours generated for a 2-hour period. So that gives us 3 kilowatts of energy being generated. From midday, from 11 a.m. to 5, we could roughly see about 21 kilowatts being generated. And that evening time, we could see roughly another 3 kilowatts. So I meant within a day, we could see roughly 27 kilowatts of energy being generated with solar panels. So part of the study was we clamped the temperature of the Cotswold tank to see how much electricity, kilowatts, is needed to heat up the water. So part of this graph shown on the bottom left is that base temperature of the water being heated up to, in this case, the example of the farm was heating up to 88.5 Celsius. And we could see from just doing calculations that for every 450 litre tank, the Cotswold tank, to heat up it by 2.16 degrees required 1 kilowatt of energy. So that meant that for us, we could see that if we have 27 kilowatts harvest that day, that we could heat up our tank well beyond 50 Celsius in temperature. So it means that if our tank was sitting at 25, we could use all the energy from that to heat up the water tank to about 75 Celsius. So in effect, what we're looking at doing is trying to use the energy that's been generated during the day to actually store it in the water and heat it up, rather than using maybe batteries or selling it back to the grid. And that's a way of harvesting the energy and using it to heat your water tank. And the basic profile or concept is that during the day, you have energy being created, getting stronger from the solar panel. And what we're looking at is increasing more cold water as the day goes on, and there's enough energy coming to heat up that water. In terms of trying to, I suppose, provide some visibility on that, we developed a dashboard and during the project, and that was trying to break down and show the vacuum pumps per farm, the milk pooling and the water heating where energy has been used. And also looking at in terms of what's been used in the mains and also what's coming in your solar panel. So this is for a particular day that wasn't overly sunny. And also at the bottom here on the right hand side looked at providing a way of looking at the water temperature as well and seeing the use of that there. So this dashboard is just a prototype, a starting point to try and give some visibility into where energy is being used. So a farmer could examine this and see if their vacuum pumps were higher or lower for a particular day. And I should say here in the graph, it shows that the black box is there, is showing what your average is. So you could see for this particular day how you compare to your average use. And if it was unusually high, that would allow you to investigate that further. I suppose just to kind of summarize, we're at this project for us really give insight into where energy is being consumed within these significant energy users. While it was only a 6-farm study, it gave us great insight into some of the challenges that you see within farming. It does highlight some areas for reduction, and it reinforces what John was saying about obviously using water plate coolers, pre-cooling, and the variable speed drives are significant areas that to invest in to try and reduce your energy consumption. We definitely see the opportunity that renewables provide, that there are clear areas where you can reuse the energy that's been generated during the day to heat up water as one area. And, it depends on the size of the solar facilities you have. You can get more than 27 kilowatts from what we've seen in this initial study. I suppose a point as well to notice, coming from a research centre, there's great opportunity here for using artificial intelligence as well. There's a great example there, one of the farms we've seen where energy consumption was really high on the robotic, not the robotic farms, sorry, on traditional farms. And I was due to servicing of a compressor. So using things like some tools like AI, there's a great opportunity to automate this analysis that can highlight unusual anomalies within energy consumption and can highlight to farmers to investigate as well. So us from a research perspective is very interesting that we can see opportunities to bring in AI into the dairy sector as well. So I'd just like to stop there and thank some of the colleagues there involved in that project as well, and Jason Ag Research for funding and Dave Farm for support as well. Thank you.
Okay, Jim, thank you very, very much for that. Just again, a reminder to all, if you would like to put any questions in the Q&A panel, that would be great. Okay, then, Jim, if you want to stop sharing there and then allow William to share. So our final speaker taking part will be William Dean. He's head of projects at Action Renewables, a charity which is driving the adoption of renewable energy in Northern Ireland. William supports the delivery of renewable energy projects in the private and public sector across electricity, transport and heat. And he's going to discuss the range of renewable electricity generation options available to farmers. So I'll hand over to William if you want to share your slides.
Yes, thank you, Jason, for that introduction there. Much appreciated. Thanks for the invitation to come and have a few words with you here today. And so I'll make an attempt here to get through the presentation. Greatly appreciate very interesting work there by John and Jim, and some sentiments there I can really relate to. So yeah, just into the first slide, I want to give you a bit of input into Action Renewables, who we are and what we do, so to speak. So we are a registered charity and we are a company limited by guarantee. What we do as such, our vision is that Action Renewables supports a world which recognises the climate emergency and will take measures to prevent and mitigate against these impacts. This is through using renewable energy, energy efficiency, renewable transport and renewable products. Some of our charitable objectives, just mentioned there on the screen, is to protect the environment by promoting energy efficiency and the use of renewable technologies, to advance the development of educational resources to inform the general public about the impacts of climate change, focusing on how energy efficiency, renewable technologies, renewable heat, and electric sources can make a difference in reducing carbon footprints. A bit of a mouthful there, but in short, we advocate, we educate, and intervene where we can. So I just wanted to share, from my perspective, doing a bit of research. This is from DERA, some of the latest statistics announced in June 2022, where I think, long story short, agriculture has been sort of listed as the largest emitting sector for greenhouse gas emissions in 2020. I think even DERA recognizes themselves, through business, energy supply, residential, etc. The penetration of renewable electricity has been a big driving factor to reduce those emissions. Transport, they mentioned themselves that probably, from the 2020 stats, COVID, I think, has driven down some of the emissions associated with transport. So that is the challenge. It's not a problem as such. That's the challenge, and we have to try and work towards constructive ways forward. So I wanted to give the context of where we are, so to speak. Essentially, the 2010 Strategic Energy Framework really set the drivers and the scene for sustainable energy development, focused on supply, renewable technologies and energy efficiency. And it set a target of 40% of renewable electricity by 2020. And yes, supported largely by the Northern Ireland Renewables Obligation, the NIRO, as we've seen there on the screen. I think we've been doing quite well. It's safe to say we've met the 40% renewable electricity target. And I think we're sort of averaging anywhere between 40 and 50% of renewable electricity penetration, depending on how much the wind is blowing and how much the sun is shining. Some points, I suppose, maybe not covered here is there has been, support mechanisms for renewable heat and renewable transport. Some of them not as successful as others, but we'll leave that there. Again, where we are, the NIRO, Northern Ireland Renewables Obligation, has been a resounding success. Almost 24,000 stations accredited under the scheme, 2,147 megawatt of installed capacity. It sounds like really big numbers, and it's something to be proud of what we have achieved. But we must be mindful of 22,230 of these are smaller scale solar PV. Yes, the majority of them being domestic installations. The graphic on the right is borrowed from DFE themselves, fairly recent one, and sort of outlines the percentage of renewable electricity and where we're getting those sources. Predominantly wind, almost 85% of our renewable electricity is coming from the wind. Biogas, somewhat smaller representation, solar PV, biomass, etc., all smaller. So where are we going? Sort of trying to set the context of where we're at and where we're going. So 2019, the UK government committed to net zero by 2050. We have closer to home the 2019 Night Rates Directive, with the 2021 energy strategy path to net zero. There's been an awful lot of consultations and work still to be done there. 2021 Green Growth Strategy and Climate Action Plan, talking maybe coming out next year, and the 2022 Climate Change Bill, and some of these screenshots there. The question I keep asking myself is, there's an awful lot happening in the sector of renewables, renewable electricity, renewable heat, and efficiency, energy efficiency. What will 2023 bring and beyond that? So again, where we're going, the 2022 Climate Change Bill has committed Northern Ireland to the net reduction of greenhouse gas emissions. That's 100% target for 2050. And I think we've been around the houses on some of those targets regarding different bills, etc. But I think we're pretty clear where we're at. The big one there is the 80% of electricity consumption from renewable sources by 2030, and the setting of reporting of carbon budgets, which is an interesting concept for Northern Ireland. I think the earlier statistics sort of showed we're averaging around 50% or upwards of 50%, between 40 and 50% of renewable electricity from demand. Basically, a jump to 80%, someone might say, well, I mean, we're doing okay. A few more wind farms, etc., will get us up to that figure. But we must be mindful that the DFE energy strategy has talked about high gasification and high electrification scenarios. Basically, we'll need to overextend ourselves by quite some bit, given where we're coming from, to meet that 80% target, because we will be using an awful lot more electricity probably going into the future. To talk about some of the solutions, and I suppose this is at a high level, and I appreciate every site is different, but we can talk about solar PV, and listening to John and Jim talk about PV, I think we're on the same page here. PV itself, established technology, it's a fairly low capital cost, low maintenance, and regarding some of those statutory and regulations, etc., a lot of them do meet the permitted development as far as planning is concerned, and favourable grid connection consents depending on the scale. They are well suited for small, medium scale energy users, and they are commonly installed alongside the battery energy storage systems. And that, I think, as what John sort of highlighted, is very important going forward, given shifting the demand from at a time when the sun's shining, electricity is being generated, but it doesn't always complement where your energy demand is. If we can load shift from the time where there's a lot of electricity being produced to the demand being highest, you can really drive some efficiency there. So this is a quick installation example from my perspective, and this would be what I would call the lowest hanging fruit in regards to solar PV on a three-phase installation, which I appreciate not everybody does have, but this is sort of ground zero as far as I'm concerned, and that is looking at a 12 kilowatt system at a cost of about £14,000 or so. It'll generate about 10,500 kilowatt hours per annum. Payback is in the region of 4.25 years, and it's offsetting about 3.5 tons of carbon per annum. And those figures would be conservative. I appreciate that, and they're a bit of work, probably site specific. Installations do benefit from the economies of scale. As I say, you could go into a full G99 application with NIE networks and install a much larger system. But as I say, for me, that is the ground zero. That's the lowest hanging fruit that should be a starting position for anyone. From that, you can build upon that with battery storage, for example. Looking at wind turbines, we have been quite successful under the NIRO in developing a lot of systems and schemes, etc. There is larger and more efficient equipment now available. A lot of those wind turbines installed in the country to date, were of a significant age by the time they're even commissioned, probably reconfigured, refurbished, and reinstalled. We're seeing turbines now that are nearly twice the height of some of the precedents, much larger blade diameters, and they're generating, maybe double the output. And that has driven, sort of maybe a market there where repowering, existing wind turbines supported under the NIRO are being repowered as such, replaced. Wind turbine is well suited to medium and high energy users. They will require planning approval, not always the most straightforward to achieve, but certainly there is plenty of sites, etc., in planning. They are getting through, slow but steady. But one of the things typically in their Northern grid connection side of things, they'll need the full G99, typically given the scale of your standard turbine. As I say, we already have 780 installed under the NIRO scheme. Those are predominantly in the 250 kilowatt range, generating anywhere between 400,000 kilowatt hours and maybe 1 million kilowatt hours per annum, depending on the scale and efficiency of the turbine. What I would talk about here is there is a future support mechanism being rumoured, and it is just a rumour at this point, and it's referred to as the contracts for difference, the CFDs. It was, I think, Northern Ireland's intention to avail of the scheme over in GB, I think Whitehall has perhaps maybe put a dampener on that. What we're maybe we'll see a consultation in the new year is a Northern Ireland specific contracts for difference. But as I say, this is rumoured, but we'll all be anticipating that with eager ears. Parameters are not yet known, but it might be for larger installed capacity machines, megawatt and above. But what I would maybe sort of prompt is, wait, watch this space and we'll see what happens. So looking at anaerobic digestion as well, well suited to extensive energy users, volumes of feedstocks available. Yes, they maybe would suit the dairy farmers with large herd of cattle, lots of manure, and a lot of acreage then to essentially service an AD plant. There will be significant planning approval hoops to jump through, so to speak, but they are getting them passed. NIE grid connection again will be needed if you're going to be generating renewable electricity for on-site consumption and exporting any excess to the grid. We believe that there's about 90 AD plants built in Northern Ireland currently, and those have been all predominantly to service the 140 CHPs that have been commissioned and accredited under the Northern Ireland Renewables Obligation. That's a figure we sort of anticipate will be increasing over time. Any of those current operators will be or should be having a look at the likes of the Road Transport Fuel Obligation, the RTFO scheme, which, as I say, should be appealing to operators. That is driving the production of for example, using waste feedstocks to produce biogas, upgraded typically to biomethane, and then used for transport purposes. Looking again, closer at anaerobic digestion, future opportunities are suggested in the form of biogas injection to support renewable heat development. Report completed by KPMG. This was commissioned by Action Renewables. We were working in conjunction with Phoenix, Firmus, and SGN. It was the supporting a renewable gas sector in Northern Ireland. There's a wee snippet of it there on the right-hand side. Showcases the potential for further biogas development in Northern Ireland, outlines some of the policy requirements, potential support mechanism, and precedents that are there within the EU and beyond. So I've maybe titled this carrot and stick, so to speak, and this might be some of the drivers. We've seen some of the carrots in regards to the NIRO. We're talking about maybe potential CFDs, etc. These are maybe the carrots to try and get businesses and the farming community, etc., to further explore renewable technologies, generate renewable technology, and increase efficiencies. But what we're seeing here is the uptake, I suppose, of corporate social responsibility, which essentially is pointing businesses and to be socially accountable to itself, its stakeholders, and the public. And basically, it operates in a way that enhances society and the environment instead of contributing negatively towards them. One of the newer buzz phrases, I suppose, is the environmental, social, and governance, ESG. So it refers to a set of standards for a company's behavior used by socially conscious investors to screen potential business partners and encourages responsibility. It focuses on how a business can safeguard the environment, basically addressing climate change. Social criteria examine how it manages relationship with employees, suppliers, customers, and the communities where it operates. And I'm sort of thinking at these, it's terminology. Even recently, I've been asked about training on ESG, etc., and carbon literacy, etc., from businesses. What I'm thinking is that farmers and dairy producers, they'll be producing obviously milk and goods, etc. They'll be working with suppliers in regards to, it could be Tesco's, it could be Asda, it could be Sainsbury's, that and many, many others. But what you'll see is that they're continuing to sort of pen this phrase, from field to fork, and whether it's, from the dairy to the fridge. Basically what these companies are going to be putting, basically, I suppose, more emphasis on you, the producers, in order to be visible in regards to your value chain and basically your production methods, etc. They'll be wanting reassurance that you're being as green and as carbon friendly as possible. They want to be able to advertise that and the green credentials that come with it. Basically, I suppose what I'm getting at ultimately is If you're producing green electricity, you're reducing costs on site. You're obviously then benefiting from the green credentials associated with that, and that can be forced up the supply chain to your benefit. So how can we help? Action Renewables offers a range of services to aid the further deployment of renewable energy, technology and products. Consultancy services, feasibility studies, energy audits, NIE networks, grid connection applications, rock trading and PPA services, tender and project management. There will be the vast majority of those listed on our website, and happy to take any calls or anyone to reach out to me for more information. One final point just from myself, further how we see we can help. Solar as a service, offering for SME and small to medium enterprise and farming community. What it is just basically a renter of program, aims to deliver zero cost solar PV installations where we would retain ownership of the system and are responsible for its operation and maintenance. We see it removing the barriers to development in regards to capital cost, statutory and regulatory compliance issues. Renewable electricity generated on your roof is delivered to you and invoiced at a pence per kilowatt hour consumed. And we believe it's a mutually beneficial route to decarbonisation. You would benefit wholly from the green credentials from there. Happy to take any questions on that. Happy to reach out to anyone. Happy for anyone to reach out to me on that in particular. And that's the end of the presentation, Jason. Any questions? I know we'll be taking questions at the end, but thank you.
Thank you very much, William. So what we're going to do now is move on to the Q&A session. I'm glad to see there's a few questions coming in there. So keep going. So we'll do this for roughly about 20 minutes or so, or we'll wrap up before 2:30. So the first question is from Jack, and I'm not sure who would like to take this. Maybe William, for you. What is the life of solar panels, and are there any ongoing upkeep costs to solar panels?
Yes, happy to comment on that one, Jason. I mean, from our perspective, we do own and operate a few of them. The lifespan of solar panels themselves, the lifespan of solar panels themselves will be in around 25 years. Other supplementary equipment such as inverters, etc., would have an expected lifespan of about 10 years, and they will be warranted, appropriately. There's no moving parts as such with a solar PV installation. You would be unlucky, so to speak, to see any typical failures prior to any of those warranty periods, but they really are, as I say, some of the lowest hanging fruit.
Okay. Thank you. I should also just point out, sorry, apologies. Chris Osborne has also kindly joined our panel session. Chris, for you who don't know him, which I'm sure do, is a Senior Policy Officer at the Ulster Farmers Union for Dairy and Rural Enterprise. So maybe a question here for Jim, although John might want to kind of chip into this as well. How can an individual monitor power usage of each part of the milking, cooling, washing process? So what's actually involved in doing that, Jim?
Well, I suppose we used energy data loggers that you can buy off the shelf from a company like Emon, and it's a fairly straightforward process where you can connect your Emon, your data logger, to your internet. So often can be through Wi-Fi, and then you have clamps that clamp around the cable that you want to monitor, and that can push information back to an online portal. It sounds maybe more technical than it is, but it's very much out of the box that you can get a simple unit to plug into the mains and connect it to the I suppose the energy user that you want to monitor. So if it's vacuum pumps, there'll be an electrical connection to that. You can clamp that cable and monitor that, and the information will be sent back to a website effectively. There are them systems that are out of the box you can use to monitor individually.
Okay, thank you. John, do you want to add anything to that from your experience?
Yeah, I'd agree with what Jim said. That's the best and cheapest way to do it, and easiest way to do it. I suppose the technology for doing energy monitoring, it's never been cheaper or more available. We'll say when I first started looking at this maybe 10 or 12 years ago, a lot of the systems that were available were very unuser friendly, we'll say. The software was terrible to use. The clamps were enormous, and it was very difficult to get them into the places that they needed to be. But now they're much smaller. They're much more compact form factor. They're all wireless communication back to a display point. So there's really a lot of easy, cheap ways to get into it and start getting some information on the desk in terms of what's going on.
Okay, thank you very much. There's a question here, and interesting one from Cormac McCurvey. There are a lot of PV suppliers. Is there a way of assessing which panels are best suited for farm use? Chris, do you want to make a comment on that?
Thanks, Jason. Good afternoon, everybody. I think the challenge is that every farm's different, and everybody's requirement is different. And I think that there's no sort of one size to fit all approach. And I think if anybody was on the call from the electricity storage company, they'd probably be best placed to answer that, Jason. But it's just all different on an individual basis.
Yeah, unfortunately, sorry, Eddie, I had to apologize. He was meant to be on, but I couldn't make it there. I mean, actually, on that kind of point, there is a question here from Gary Watson. On-farm battery storage in terms of cost and payback seems to be a challenge. Is this likely to change in the near future? I know, Chris, you've just kind of done an affinity deal with the energy storage company. Now, obviously, unfortunately, Eddie couldn't make it on today, but is that now becoming a more realistic option?
Most definitely is. It's the only way I think it's going to progress without any indication from government on what future support is going to look like for renewables. And maybe come back to later on about the more high level challenges that exist here as a sector. But in terms of the here and now, battery storage accompanying solar PV is a perfect fit, and the same basically applies to small scale wind.
Okay.
I would echo what Chris has said there as well. Jason, just on the point regards to essentially the payback in regards to solar PV. I mean, we've seen solar PV as a technology reducing cost by some 50-60% even in the last 10 years. Batteries and battery energy storage systems, they're relatively new on the ground. We've seen them coming in over the last 4 or 5 years. Have been coming in at a pace, and their battery installations happening quite regularly. The price is, in some cases a limiting factor. But I believe that, as the technology develops, as it matures, and they become, higher uptake for one, once there are more people seeing the benefits of that, we'll see prices maybe from different installers and sources becoming more competitive. We can see those coming down.
Absolutely. And I think another thing worth pointing out as well is BEIS in England have released, I think, in the regions of £25 million worth of funding here looking at storage. Now, it's not just the sort of conventional, inverted commas, battery storage, but there's other types of storage as well, which would probably be, once they come into the public domain, reduce the cost. And I don't think there's any, well, I know there's nothing similar here in Northern Ireland coming from DFE, and we do need to have further evidence, public and indeed clear evidence from DFE that they're serious about this, and to have some form of funding for further research in terms of storage.
Absolutely.
I might just make one comment, Jason, on the storage side of things. I suppose just tying in with what Jim was mentioning earlier. So look, for small to medium sized PV systems, I think the hot water heating system is the first port of call for storage on dairy farms, because it's just such a cheap way of storing energy, and then as systems become bigger and start to get to 50 or 60% of annual demand or higher, then you're going to have to make the call of do battery storage, which is logical if there's no significant export tariff, which, let's face it, it's probably unlikely there will be going forward, or building the battery. So I would do it in that order in terms of storage,
Unfortunately, John, Power NI up here 10 years ago had a solar water heating scheme, and the uptake was actually very, very poor. So, we've been there already, but I think that would need to be sort of brought back to life again, I think.
Was that for solar thermal, Chris, or was it for solar PV?
Solar thermal.
Yeah. I guess there's a couple of things that have happened, at least in this part of the world, since then, maybe that might change the environment a small bit. And one is this these chlorine-free detergents, which are kind of becoming, well, they're mandatory now down south. And that's placed enormous pressure on water heating systems because most farmers now would be hot washing their milking parlours at least once a day, sometimes even twice. So like the figures I showed earlier, where water heating was 25% of demand, I think that's actually creeping up even over the last 12 months and could be likely to hit 30% going forward.
One wee point from myself, just in regards to the cost and the payback, etc., for the renewables, what we are hoping, or what actually Renewables is hoping to see, is something tangible from the current energy strategy. Since the closure of the Northern Ireland Renewables Obligation in 2017, we haven't seen any support mechanisms or even any soundings of a support mechanism for, I suppose, microgeneration or some of those smaller scale technologies. Any developments so far in basically solar PV and battery installation side of things is market driven, and that is basically on the savings from the electricity. And because electricity is so high in cost at the minute, there's no guarantee those costs are going to remain as high as they are. Yes, they'll probably be volatile for a number of months and years ahead, but what we really need, or what we would like to see, is Department for Economy through the energy strategy implementing a support mechanism that'll put a tariff on export electricity at a very minimum. What would be massively preferential would be something that will support the sector itself in regards to, if someone wants to invest in a battery, there's going to be a support. It's pence per kilowatt hour, it's grant, it's something. Anything will be better than nothing.
Absolutely. And as a plug for my commodity watch that's coming up on the paper next week in the Farming Life, we were there with ROCs, we were there with, dare I say it, RHI. There's a little bit of hesitancy out there in terms of future support, but there should be a focus on energy efficiency on farms, and in this case dairy farms, and some form of payment or some form of scheme that could be sort of linked to energy efficiency, for example, need to be looked at, but also as well focus on the co-op option as well, which seems to be getting a bit of traction, whereby anybody in the sort of locality would sort of benefit from have smaller electricity bills if there's a farmer with renewables on their premises, so the co-op model is one that sort of the UFU are definitely looking at.
Okay, another question here from Peter McCann and for William, and you rightly, William, you were talking about the various silos under which the greenhouse gas is allocated, and one of the issues I suppose he says is if a farmer installs renewable energy technology, will that help reduce emissions from the agricultural sector or the energy supply sector in the national GHG inventory? I think this is one of the big issues here is, because, and I think it was a comment also earlier, that there's a limit to what we can do currently to reduce carbon from agriculture to zero. It's a biological life cycle process. It's not going to work that way. So, we very much need every bit of help we can from, let's say, land use and from renewables to shove that over into agriculture. Have you any idea, how that might work, or is there any talk on that?
Yeah, I mean, I was keeping a wee eye there on the questions came through, and I think someone mirrored the sentiment there as like an anonymous attendee, that they wanted to point out the energy sector benefits from farmers' investment in renewables. So they're asking the same thing. I mean, from my experience working at the coalface and working on some of the administration behind some of the projects, we do know that a lot of these individual wind turbines, etc., set up in the electrical configuration that they have, they're 100% export to the grid. Now, I'm not saying all, but I would say it's probably a majority, maybe 60% of them would be. And yes, any of the carbon savings, for example, and the greenhouse gas emission avoidance as such, that follows the renewable electricity onto the grid. And yes, then the grid would claim a lot of those benefits. What we would maybe see going forward is that a lot more of the renewable electricity being used on site itself. So then, therefore, the farmer would be benefiting from the renewable electricity and the consumption of that. And that's been, I suppose, somewhat molded by some of the changes we've seen in the position of any networks themselves, there's not an awful lot of export capacity available on a congested network. And a lot of the connections now becoming available, the more successful applications are actually referred to as zero export, in that renewable electricity being generated from a PV system on the roof or generated from a small to medium scale wind turbine, but it's not allowed to export that electricity onto the grid. So therefore it must be consumed on site, or the technology is actually shut down, like a reverse power protection. That is the sort of thing we want to see. We need to see the farmers using more of this green energy, claiming those emission savings, and therefore being able to literally send those green credentials to the moon, shout and scream about the benefits of it. And that's, yes, through the generation technologies, batteries, everything.
Chris, you want to make any comment there from your end?
Yes, again, only off a call an hour ago, the working group I sit on for carbon audits, and I think that as far as the dairy industry is concerned, for example, sitting here with two hats on, or maybe both hats if it's still possible, is that any sort of renewable energy on farm will need to be taken into account in terms of the carbon audits, whichever way they may roll out in Northern Ireland.
Okay, that's grand. And John, has there been any discussion down south on how you kind of bridge those two silos in the inventory?
Yeah, it's probably above my pay grade, to be honest with you, but it's the same discussion. The on-farm generator renewables, be they used on site or be they exported, the kilowatt hour offset is attributed to the energy sector, and it's a bone of contention, I suppose, among the farming community. I guess in absolute terms, it's probably quite small in terms of the targets that are set in terms of its contribution, but that's not really the point. It's kind of it's more of I guess a positive feeling that farmers could contribute to the targets in this way. That's kind of missing there, so yeah, I can't see much movement on it. To be honest, I think it's fairly entrenched in terms of how those emissions are calculated for reporting at the national level. But I suppose on the individual farm level, the PV generated electricity will be taken into account when Board BIA calculate the farm's carbon footprint on an annual basis. So if a farmer puts in a PV system, they will see it reflected on their sustainable audit documentation when that number is presented on an annual basis. So at least it's visible in that sense,
Okay, thank you very much. Maybe a question for William here. Are smaller vertical axis turbines more efficient for home or farm use?
Oh, that's an interesting question, Jason. What I have seen as a bit of a trend is that even through the turbine repowering in Northern Ireland, people are taking down essentially turbines and they're replacing them with larger hub heights with a greater blade diameter, and those are typically operating at a much higher efficiency or capacity factor, and the electrical output from them is maybe in some cases doubling. That's the general trend, but at smaller scale, I wouldn't have a terrible amount of experience with them. But vertical axis turbines, I know they're in the market. I haven't had much experience with them, but obviously keen to see if there are any what the benefits are as such. But yeah.
Okay, thank you. And then maybe a question for Jim. I'll also let John come in after that. How effectively can PV energy be directed to water heaters? And where there's a lot of domestic systems are designed to automatically switch on heaters, certainly if there's surplus to requirement. But how easy would it be to install a smart system that would kick on your water heater, your ice bank, or whatever when you've got surplus energy to requirement?
Well, that's something we're working on at the minute, developing a small prototype system on that. But for domestic home use, I mean, it's quite common that people use solar to heat the water, and that closed loop system does exist and it's not expensive. Moving into the dairy sector, we're looking at trying to build a prototype, and I think we're looking at less than £200 to try and develop a system like that. It's not complicated to do. And it doesn't require an extensive rework. It's a small retrofit the system. So I think it'd be low entry to try and do that. We haven't come out there and seen bespoke systems in the dairy sector to do that, but we know domestic systems are available and they're priced just below that price point.
John, have you any experience in this?
Yeah, it's very typically done, built in as standard as part of the dairy offerings for solar. The most common device I've seen is an eddy device, power diversion device, that just simply sends any excess power in periods of low demand to the element of the water heater, and that soaks it up then. And when the water heater is full, it'll export off out to the grid then as usual.
That's grand. Okay. Maybe William, question for you here. For someone who's on single phase and not, financially an option to install 3-phase, what are the options for renewables, wind or an AB plant or whatever else in the future? So what's the options for those guys who maybe are going to, due to the distance of 3-phase lines, would struggle to bring 3-phase to their farm?
Yes, I think it's an ongoing issue, Jason. I know it's a question for NIE networks essentially, and I do understand that it's not always perfectly cost feasible to bring 3-phase to every property or every premises. Unfortunately, through the conventional sort of connection avenues, on a single phase installation, you're maybe more restricted. For example, even on installing PV, for example, under a G98 NI application, you're restricted to 3.68 kilowatts of solar PV. Now that's, I always preach about progress rather than perfection. That would still be better than absolutely nothing, and I'd probably advocate for that. But there would be maybe potentially, and you'd have to speak to an electrical engineer, there may be behind the meter arrangements, for a microgrid on site that could be, generating at a 3-phase level. But again, you wouldn't be able to export that power onto the grid. So it would need to be all consumed on site. And that's where the question lies. And I mean, there would need to be some very detailed plans from an electrical engineer pulled together at that point. I do know it's possible. I've seen and heard of it being completed. Even Ofgem's familiar with it and I'm comfortable with it. But going forward, a lot of the easy wins are attributed to the 3-phase electrical connections. I appreciate that comes at a cost.
I mean, there's actually a comment there from Thomas Martin, and I think William or maybe Chris wants to come in there. Do you, the panel, think that current electricity network should be upgraded to allow all farmers to access 3-phase electricity supply? Is this in the national interest? Because farmers are an obvious source of renewables, but they're constrained. Has there been any discussions with like say NIE to kind of look at, well, how could we upgrade the network to allow more farmers to put in more meaningful renewable facilities?
Yeah, that's okay. I'll just jump in front of you there, William. NIE worked to what they call the RP program, which covers their business plan for a 6 to 7 year period. So in my time in the job, I have contributed to RP5, RP6, now RP7, which is 2024 up to 2030, and in NIE's networks business plan. I think last time it was in around the £700 million mark. It's now 1.4 billion. And parts of the low voltage network could be as old as 70 years old plus. And like the UFU have made the case for basically upgrading lines where possible. Money should be focused and indeed put towards bringing them up to 3-phase. And, our voice went in, and that RP7 then goes to the utility regulator. In terms of austerity, etc., in modern living, I could see the utility regulator unfortunately putting a red line through that 1.4 billion and bringing it down in the interest of protecting the consumer. But yeah, we have made the case for basically rural lines to be brought up to 3-phase where at all possible. Now, if we're going to get to 2030 and the 80%, the electricity grid is already under pressure, and if we're bringing in electricity vehicles and electric heat pumps, electrification of transport and heat is going to put even more pressure on. So it gives more of a case for basically bringing those dinosaur lines basically up to grade, up to spec.
The only thing I suppose maybe I add there was even Sony themselves have recognised the need for electricity infrastructure upgrades, and I believe, don't quote me, but I think they promised up to £500 million to be spent in regards to some upgrades on certain key areas and congestion points, etc. it's going to be a long drawn out affair, and appreciate that it's not easy to get three-phase electricity to some of the more rural areas, etc. There's clear benefits, but like everything else, slow and steady progress wins the race. Hopefully everybody will be able to benefit at some stage. Keep fighting the fight and shouting your case.
Will do. I think just sort of, Jason, just to follow on to that, I think I noticed there that Karen Arbuckle made a point, and I think this is one that needs to be emphasised. I mentioned the co-op model, but also the community solution. And the community solution won't get anywhere until we get movement from the utility regulator into, there's a phrase called wheeling. And wheeling's currently illegal in Northern Ireland. And what that means is you could have a farmer on a dairy farm, for example, with I'm not going to give the scale of the wind turbine, but they could be providing electricity to a community. And from that wind turbine, the farmer would obviously get the financial benefit in terms of the tariff, etc. But that is currently illegal. That process is known as wheeling, whereby a farmer can sell that electricity to a community. So, again, there's a big box that needs to be ticked there and needs to have action taken.
Yep, corporate PPAs, fall under the same sort of principle. Where essentially if you had a willing generator and you had a willing electricity supplier, they'd be able to do the paperwork exercise to reconcile the two. Yeah, it's something I would love to see, maybe addressed in the likes of the energy strategy. Is willing going to make a comeback, and is corporate PPAs, the sort of the development of those, that they'll help in that case, for the community energy aspect greatly.
Okay, I'll just have one last question here. So one of the issues is, Karen again is saying here that since our the number of suppliers for solar PV and so on has kind of gone, and we aren't as competitive as GB. Is there any growth expected in that supply? And the other question you just asked quickly here is there any research on geothermal for agribusiness? So William, do you want to maybe comment on that?
Yes, thanks, Karen. I mean, very, very, very prominent questions there have been asked. We've been installing some PV of ourselves recently, and what I have found is that with the increase in electricity prices, I can quite literally say that I have seen PV installers coming out of the woodwork. I've seen some that are presenting themselves very well, and others that I names that are maybe more obscure, but if in doubt, always refer to the microgeneration certification scheme, MCS, which will outline verified installers in your area. And I think even this year alone, we've seen quite a few that have applied and are being represented under MCS. Of course, there's many that aren't, but always use your own intuition and go for any referral or references, etc. I've seen quite a few more people installing PV and doing very good jobs. And I hope, yes, certainly prices will maybe decrease, and as competitiveness increases, let's just see what comes from that.
Okay, thank you. Well, listen, I'm going to wrap it up there. My sincere thanks to John, to Jim, to William, and to Chris for participating in today's webinar and their contributions. I think it's been, the talks are very interesting. I think we've actually also in the discussion session highlighted a lot of the big issues around renewables and the barriers to adoption and so on. So my thanks to them and to all of you for attending. A copy of the recording of the webinar will be on our website and YouTube channel in the coming days. And finally, I do request kindly if you could fill in the feedback survey, which will appear at the end of this webinar. This feedback is invaluable in helping us to plan future events. So thank you all very, very much, and good day.